Hello guys, so today we'll be doing LeetCode question 200, which is number of islands, and it's a medium question. The question is, given an m by n 2D binary grid, which represents a map of ones which represent land and zeros which represent water, turn the number of islands. So example 1, the input grid is an array of arrays. So the first array is 1 1 1 1 0, second one is 1 1 0 1 0, third one is 1 1 0 0 0, fourth one is 0 0 0 0 0. The output is 1, as you can see, because the example of ones, they all connect. So there's ones connecting here, they connect to the other ones, which connect to the other ones here, and connect to the other one here. So that's one island. Example 2, the output is 3 because there is one island here where they connect. These four here. Then there's another island here, none connecting above or beside, horizontally or vertically, and none connecting here. So 3 islands. So yeah, so as long as they connect horizontally or vertically to that one, that's one island. Diagonally, doesn't count. So the way we'll do this is we'll have a double for loop, and each time we find a 1, we check the islands around it, the items above, below, and beside. For example, this one we'll check above, below, beside, and if there are a 1, we turn them to 0, and we count all of that as 1. So let me show you what I mean. Whiteboard. So let's say we'll initiate a count off here to represent the islands. Okay, that's very bad spelling. Let's go count. Count. Then let's say we have a grid here, and that grid is, why is this in the way? 1 2 3 4. That's 1 2 3 4 5. 1 2 3 4. So let's say it's 1 1. I believe it was 1 1 1 1 0. 1 1 0 1 0. And it was 1 1 0 0 0. And it was 0 0 0 0 0 0 0 0 0 0. Something like this. So we'll start. I'll go for a double for loop, and we're right now in this position here at 1. So we have 1. So now we set this one to 0 here. This is now 0. Now we check the recursively. We check the top. If it's inbound, we check the top and left column. Now top is not inbound, so we don't check the top. Left is not inbound, so we don't check the left. Now we check the right. Right is inbound, so now we're at here. 1. Now we turn that to a 0. Well, the reason we turn to 0 so that we don't, well, as we move to the next one, for example, if the first one was still a 1, we will check that one again. Recursion will never stop, which will cause an infinite loop. That's now 0. Now again, there's nothing on top. Here, there's nothing on the left because that's a 0. There's no 1. So we go right again. So now we're here. Now that's a 1. Turn it to a 0. And there's nothing on top. Left is a 0. Go right again. We're here. Now we turn that to a 0. Now we go again. Nothing on top. Right is 0. We don't go there. Now the bottom one is a 1. So we now here. Turn that to a 0 as well. Now on top is 0. Right is 0. Bottom is 0, left is 0. So now we go back up from here to here, from here to here, from here to here. Now the right is 0. Now we check the bottom again. Bottom is 1, so now we're here. We turn that to a 0. Here. Now is the right is 0. Now the bottom is a 1, so now we're here. Now we turn that to a 0 as well. Bottom now right here is empty, bottom is 0. I mean not empty, 0, bottom is 0. Now left, that's a 1. So now we're here. We turn that to a 0. Now we go back, we're here, right is 0, bottom is 0, left is out of bounds. Now top, there you go, top is 1. So now we're here. Turn that to a 0. Now we check the top, left, they're all zeros or out of bounds. So we go back up, bang, bang, bang. Here, and we go back to here. Now, as we complete all of it, now we return 1. So we add 1 to count is 1. And we go next. So we go here, let's get the other bracket. It was here, now we're here. Now we're here, 0, 0, 0. Pretty much every time we go through 1, get to 1, we keep iterating this loop recursively. Now let's say there's a 1. Let's go here. Say there's a 1 here. 1. Now again, we will now set that 2 as 0. We'll set that 1, 2 as 0. Now we will check the outsides. Top is 0, left is 0, right is 0, bottom is out of bounds. So we then set the counter 2, and we get to the end here, and now we completed it. However, the first question does not have a 1 there, so the count will just be 1. And as we get to the end here, we've completed it. So pretty much when we get to a 1, we check all the surrounding squares recursively, and we turn each one to a 0 to stop the infinite loop. And when we completed that and turn all of the 1s to a 0, we count that as one island. So let me show you how it's done in code. So the first thing we do is we initiate a counter to 0 to represent the current islands. Then we create a function to recursively check the surrounding islands of the current position. So we call it check islands. And to check the position, we have to pass the grid and the row and the column, so we can get a position. Then here we check if they're in bounds. So if the row is smaller than 0, we know it's out of bounds. Or if the row is smaller than the grid.length minus 1, we know it's out of bounds. Then if the column is smaller than 0, we know it's out of bounds. And if the column is smaller than the grid row.length, then we know it's out of bounds. And if the position, so grid row col, is equal to 0, then we don't need to count it. So for all of these we return 0, because we know that's not our island. Now the next thing we do is we set the current position. So if we've not returned 0 yet, we know it's a 1. So we set the position to grid row col to a 0 string. And then we have to recursively check each position. So we do check islands. Again, we pass the grid, we pass the row plus 1. So we check the position to the right, and we pass the column. Check islands. Sorry, the row plus 1 will be position below. Now we will check the position above, so it will be grid row minus 1 and column. Now we check the position on the right, so we go check islands, we go grid row, and the one on the right will be column plus 1, column plus 1. Then we check islands on the left will be column minus 1. So grid, row, column minus 1. So pretty much this checks each position. And once we've done all this, then we return a 1 for the one island we have found. If we find these, they're connecting, so it counts as one island. Now, we have to do a for loop, double for loop, where we check position and column each time. So we go for let I is equal to 0. So it's I smaller than grid.length minus 1, no, grid.length, then we increment. And then we do the same, so this goes through the rows, for the column, sorry, and then we go through the rows as well. So for letter j is equal to 0, as long as j is smaller than grid I.length, then we increment j. And here we execute a function for the current position that we're at. So we check islands, pass the grid, and we pass I as the column and j as the row. And then we return islands. So this pretty much iterates for each position. Let's see if that passes. oh, sorry, not return, return count. I believe that's what we called it. Yes, return count. Let's run. Okay, I see. Here, as a returning one, we have to increment it to the count. So we make count plus or equals check islands. So for each island we get, if we return 1, we add it to the count. Now let's run that. Okay, I see the mistake. Here, I have to make column smaller grid door length -1. Otherwise, if it's the same length, it's, oh wait, column is, I see, not smaller than -1. Column is bigger. That's the mistake we made here. Because if it's smaller, it is inbounds, not out of bounds. So let's run now. Function island minimum maximum full stack exceeded. Function rows grid bigger than grid door length. Oh yeah, and -1. Because it can't be equal to grid door length, because then it'll be out of bounds. So let's see. As you can see, it passes. Let's submit. As you can see, this is one of the fastest methods here. There is still fast ones, but it's one of the fastest ones. Okay, and the time complexity of this is OM of n. So M for the rows and N for the columns, or vice versa. Thanks for watching.